All right, let's go ahead and get started with Unit 1, Atomic Structure and Properties. And to start off this unit, we're actually going to talk about moles and molar mass because we have to understand how we visualize and count atoms. So our learning objective is to be able to calculate quantities of substances relative to the number of particles. And we're going to do this using dimensional analysis and the concept of a mole. We're going to break this down into three essential knowledges. The first essential knowledge you have to leave with is that we can't count particles directly in a lab. Therefore, we have to establish a connection between the masses of the substance and how many particles are there. To kind of get you started thinking about this, let's imagine this jelly bean jar of Costco Jelly Belly jelly beans. How many jelly beans do you think are in there? How would you solve this problem? Can you think of a couple different ways to do it? Now, the first way I could think of is to just take all the jelly beans and pour them out and start counting. It'll take you a few minutes, but you can probably get that done. The second way that I can think of doing it is by weight. If I look carefully at this jelly bean jar, you'll see that it has approximately 1,810 grams of jelly beans, and that's on the label. I can look up the average mass of a jelly bean, and it turns out that it's about 1.10 grams. And knowing this information, I can now calculate a rough estimate, an approximation of the number of jelly beans in this jar. And this is going to be done using dimensional analysis. And here's what it looks like. I know that the jar has 1,810 grams roughly. I know that one jelly bean is 1.1 grams. So I can just plug this into a calculator and solve, and I'll figure out that it's about 1,645 jelly beans. Now, in dimensional analysis, what I'm doing is I'm using the units to guide the math. So grams is what I'm starting with. I need to cancel out grams, so grams is going to go on the bottom, and what I'm going to goes on top. So one jelly bean, that's how much it weighs. We'll see it come up again. Now, this idea can be extended to chemistry in that we know the atomic masses of all the elements. The atomic mass is the average mass of all the atoms of an element, and we can use this to do similar math. These masses are typically found underneath the element symbols, and their units are atomic mass units, so these are really small. So hydrogen has an atomic mass of 1.008 atomic mass units. One atomic mass unit is 1.66 times 10 to the negative 24 grams. This is a tiny amount, but then again, they're tiny atoms. Now, I can take these atomic masses and use them to calculate the number of atoms in a sample. If I use an instrument like a mass spectrometer, which counts atoms by mass, then I could potentially solve a problem like this. A sample of pure copper was vaporized and injected into a mass spectrometer for analysis. The report produced by the instrument indicated a total mass of 80,264 atomic mass units was analyzed. Approximately how many atoms of copper were analyzed? So I'm going to annotate always by underlining what is given to me, putting boxes around substances so I can easily find them on the periodic table, and circling my question. And then I'm going to outline my plan. I need to go from atomic mass units to atoms. And to do that, I'm going to need the atomic mass of copper. So I can go to the periodic table and I can find the atomic mass of copper. One atom of copper weighs 63.55 atomic mass units. So I can do my dimensional analysis. 80,264 atomic mass units is what I have total. One copper atom is 63.55 units, atomic mass units, and then I'm just going to plug into the calculator and solve, and this sample will be about 1,263 copper atoms. And in this way, we can see that we can use masses to count atoms. And we're going to extend this further in future videos.